Good afternoon, everyone. Being knowledgeable is always a great thing, but being persistent in gaining knowledge is legendary. Since, for that, we, Civil Engineering Department of Guru Gobind Singh College of Engineering and Research Center, Nashik, is always persistent in organizing and participating in short-term training programs and webinars. And now, a very good afternoon to everyone. I, Sneha Sudhir Salkade, welcome you all in the short-term training program organized by Civil Engineering Department of Guru Gobind Singh College of Engineering and Research Center, Nashik, on development in water resources engineering and its practical applications. Today is the sixth day of our session, and I would like to welcome our honorable guest, Engineer Praveen Kolhe sir. He is working as an superintending engineer at Pune Minor Irrigation Circle. Along with that, I also welcome our honorable principal, our respected HOD sir, and all the staff members of Guru Gobind Singh College of Engineering and Research Center, and all the participants of this STTP. So, welcome you all, and now I respect Mrs. Pallavi Padalkar ma'am to introduce our honorable guest.
Thank you, Sneha Madam. As Sneha Madam has aptly welcomed all of you, once again I welcome all the participants and all the dignitaries in today's session. I am privileged enough to introduce famous personality, Engineer Praveen Kole sir. He is our today's expert for the session. We are honored here to have your esteemed presence, sir. Thank you for being here and granting us the permission that you will be here as an expert. Engineer Praveen Kole sir,
Thank you,
he is
ma'am.
the Superintendent Engineer at Water Resources Department, Government of Maharashtra, India. He is presently working at Pune Irrigation Project Circle, handling the responsibility of construction of water and irrigation infrastructures, including dams, canals, piped irrigated networks, small hydropower schemes, and many more things. He is currently pursuing his PhD at IIT Bombay. I must say, an incredible effort after handling all such many responsibilities. He is enthusiastic to be there at IIT Bombay for his PhD. Prior to that, he used to work as executive engineer at Pune Irrigation Division, handling the responsibility of water and irrigation management activities. Previously, he held the position of executive engineer and assistant executive engineer after securing first rank in Water Resources Department in Maharashtra Engineering Services examination 2004 conducted by MPSC. A credible effort, sir, I must say. Prior to that, Kole sir secured gold medal from SPPU, that is Savitribai Phule Pune University, formerly known as University of Pune, for being ranker in his final in civil engineering in 2004. Then he completed his MTech from IIT Kanpur in 2017. Later, in 2014, he completed IIM Indore's Executive Postgraduate Program in E-Governance. He has also completed his MBA in Finance, Master of Arts in Public Administration, and holds 3 postgraduate diplomas. Such a learned personality we have with us today here. Kole sir is honored with several awards, including Outstanding Engineers Award by Government of Maharashtra in the year 2019 for his dedication and commitments towards his duty. In 2019, on behalf of WRD, he received Geospatial Excellence Award for application of drones in water management. So we must say that this is combination of contemporary education and latest technologies as well. His participation is integrated. In integrated state water plan was appreciated by Director General of MERI. He also received Sir Vishweshwaraya Award by the hands of Principal Secretary, Government of Maharashtra in 2011. He is life member of 13 technical and scientific organization. He is speaker at conferences including India Water Week as well. He has delivered guest lectures at various institutions in India and also has designed and managed his own website known as www.pravinkolhe.com, where civil engineering study material is readily available for students. So as a teacher, I have already introduced his website to my students, and that is a valuable source of learning material to our students, sir. So we are privileged here to have you, sir. Thank you for accepting our invitation and being our guest today. Thank you very much, sir.
Thank you very much, Padarka ma'am. Now I must say that today we are having a great personality with us, and I would like to say that we all are going to enjoy today's session, and you all are going to find it fruitful at the end of the day. So now I request Kolhe sir to please guide us, and thank you
Yeah,
very much.
yeah. Thank you, Pallavi ma'am. Thank you so much for such a elaborated introduction. Uh, First of all, let me thank the institute, Sri Guru Gobind Singh College of Engineering and Research Center, Nasik, and I welcome you all in this workshop on development in water resource engineering and its practical application. And I must say I am privileged to be here, and I express my gratitude to Professor Praveen Shinde sir for inviting me to present my thoughts on urban flooding topic in front of all the experts and uh, teachers and students. So, respected principal, head of the department, faculties, staffs, and participants of today's seminar, we will be discussing the topic of urban flooding, which is a great concern for the developers and water managers. Hope my voice is clearly audible and my slides are visible to you.
Yes, sir. You are
Yeah,
audible, and the slides are visible also.
yeah, thank you. So we will start with my presentation. So first, in this presentation, I had divided in this presentation into four parts. In the first part, we will discuss about the floods and how to classify floods, various types of floods, and what floods really means. In the second part is dedicated to the urban flooding. The third part is regarding we will discuss a specific case study of the flood vulnerability of the Maharashtra state. And I will present some information about the state and the flood events. And in the last part, we will discuss the flood management and way ahead. What are the issues and challenges in the flood management? We will discuss that. So first, start with the flood, and flood is one of the disasters. So in before understanding flood, let's understand the disaster and what really it means. So we must understand the definition of disaster. So in India, we have Disaster Management Act 2005, and by in the definition of this act, the disaster is defined as a catastrophe, a mishap, or a calamity, or a grave occurrence in any given area arising from natural or man-made causes or by accident or by negligence. This is very important. So disaster can occur from natural cause or man-made cause, or if it is a man-made cause, it can be arise from the accident or from negligence. And this disaster will result in a substantial loss of life and human suffering. So accident is may not be a disaster unless it results in a substantial loss of life or human suffering, and or it may cause a damage or destruction of property, or it may cause damage or destruction of environment. For example, if there is a fire in a forest, it may not be a loss of property, private property, or loss of life, but it causes a degradation of environment, the living species damage, and loss of life of the living species in the forest. So this is also disaster in terms of Disaster Management Act. And most importantly, what when this disaster is said to be happen, the condition is that, and is of such a magnitude or nature as to be beyond the coping capacity of the community of the affected area. So disaster means which is a beyond the coping capacity of the affected area, then it is known as disaster. So once we know the what is the meaning of disaster, let's classify the disasters. So ideally, as I already discussed, disasters are of two types. First is a natural disaster, which includes volcanic eruptions, earthquakes, floods, bushfires, etc. Or these can be a man-made disasters. So man-made disasters can be a war, terrorism, chemical or oil spill, global warming, etc. So climate change is a natural disaster occurred because of the man-made activities. So in this next slide, we will discuss the various disaster risks. So disaster risk is a function of three important parameters. So in order to understand the coping mechanism for the disaster, we should understand the important factors contributing the disaster risk, which are: first is hazard, second is exposure, and third is a vulnerability. So in this slide, we will discuss these three terms individually. So hazard is a potentially destructive physical phenomena. So hazard means there is a some physical phenomena which is going to be happen and which can cause a destruction. So hazard is a that potential is known as a hazard. But like for example, earthquake or flood has a some hazard potential. So that is a hazard. Then what is the exposure? Exposure is a location or attributes and the values of asset that are important to communities. For example, if some city is situated on the hillside, then it is a prone to the landslide. So that exposure increases the intensity of that disaster. And for example, the exposure is for the people, for the ecology, for the infrastructure, for a given village or like that. Then what third term is a very important term is a vulnerability. So vulnerability is a likelihood or probability that the event will occur and it will cause a damage or destruction to the asset or the property, and it will be affected when the asset is exposed to the hazard. So in order to disaster to be happen, all three things are required. So the magnitude and intensity of disaster depends on these three factors. So in order to have a proper mitigation plan, we should consider we cannot mitigate the hazard of the disaster. So there will be some potential hazard for the upcoming disaster, but we can definitely manage that disaster using our exposure condition and making it less vulnerable. So disaster mitigation is an important part. And uh, from the perspective of our presentation, I will treat the flood hazard as a hazard. The exposure means urban population residing at a low-lying area near river. That means they are exposed to the flood hazard. And vulnerability means there is a likelihood of occurrence of intense rainfall induced due to the climate change. So all these three factors contributes and intensify the disaster risk. So India is very vulnerable to disasters because 57% of India's land is vulnerable to earthquake. Of this, 12% land is vulnerable to severe earthquakes. In terms of waterborne disasters, 68% of Indian land is vulnerable to droughts, and about 12% land is vulnerable to flood, and 8% land is vulnerable to cyclones. So from these statistics, we realize that we are really vulnerable to the disaster. So after having a brief idea about the disaster, we will concentrate on the flood related disasters. So flood, the word flood comes from Old English flood or flow, which is a Indo-European language root. So this origin of this word is from Old English words. And from the if we count the last 10 years disaster, then flood accounts 80% of the natural disaster. So you can see that there are two factors. The frequency of occurrence of flood is very high, and also its damaging power is also very high, and it is a next to earthquake. So earthquake has a less frequency of occurrence, but it has a very high power of devastation, whereas floods are having more occurrence frequency, and it also has a less devastating power. So these flood or water related natural disasters which are resulted from flood or droughts or severe storms. So flood frequency and intensity of the flood is increasing, and in the future it is expected that this intensity and frequency will also increase because of the adverse impact of climate change. So on this background, it is utmost important to take the adverse impact of the flood and to prepare a mitigation plan. The about 2 billion people were affected between year 1998 to 2017. That is, during the last 20 years, about 2 billion people were affected by the floods, and about 2 billion people were affected worldwide. And because of the maximum number of deaths occur because of the drowning in the water. So, what is the difference between flood and other disaster? So, what impact they bring is interesting to know. So, flood generally affect wider geographical area than other disaster, except earthquake. And there are the indirect losses of the flood are often much higher than the direct damages. So in the upcoming slide, one of the slide, we will discuss what are the impacts of flood damages. So basically there are two types of impact: direct impact and indirect impact. So indirect impacts are seen after the occurrence of flood is done. So flood can deform the land on which buildings are built, or they render them, or it becomes useless to use these buildings and infrastructure. So the land becomes unusable, or some infrastructure becomes unusable. So it can cause after effects damage. The flood can alter the course of rivers, thereby disturbing transport infrastructure and agriculture over a large area. Then it can also block or damage access to road, or it can also cause a collapse of bridge or building or other general common infrastructure, and this makes access and communication difficult. And because of this, the evacuation and disaster management become a challenging task. The electricity supply and supply of clean drinking water is also interrupted during the flood period. So the basic amenities or basic needs of a people could not be met with because of the floods. Flood also cause landslide, and if there is a saturated soil, then intensity, because of the landslide, intensity of disaster increases manifold. Flooding can be caused either by fresh water, air, or salt water. So, in the next upcoming slide, we will also discuss the classification of floods. So, basically, flood can be caused by the fresh water or salt water, and both has its own disadvantages. For example, fresh water carries suspended solids which leave mud and soil behind, whereas salt water makes water source unsuitable for drinking and soil becomes saline. So, agriculture productivity decreases, and there are many issues. So, if we see the flood damages during the last about 60 or 65 years in our country, about 442 million hectare was affected because of the flood, and average annual area affected is about 7 million hectare, and maximum damage due to the flood is occurred in year 1978, and in that year about 18 million hectare area was affected. And because of flood during these 60 years, 198 million population was affected. The per year average affected population number is about 3 million, whereas in 1978 maximum number of population was affected, and that number was 7 million. And in this figure, the other characteristics of the damages due to the flood are mentioned. So we can realize that not only we sacrifice the human life, but we also sacrifice the our infrastructure, our livelihood, and our living beings. So now we come to the second part of my presentation, which is related to the urban flooding. So urban flooding is a development challenge. So on one side, we are trying to develop our community. We are trying to build a new infrastructure. We are trying to improve the standard of living of the citizens. But we are also inviting the floods in the urban region. And there are challenges to mitigate the urban flood. So in the next slide, we will also discuss the difference between the urban flooding and rural flooding, and why urban flooding is more vulnerable in mitigation. So flooding cause devastation, economic loss, and loss of life and living beings, and it also causes a long-term impact on the ecology. And due to the urbanization and the upcoming impacts of the climate change, the risk of urban flooding is increased in each and every city and most of the part of our country. So we also need how future will happen. So how urbanization will progress, we should also discuss this part. So year 2008 was a milestone year in the history of human, because it was the first time the 50% of world's population lived in the urban area. So in year 2008, the 50% of world population started living in the urban area, and two-thirds of the urban population falls in low income and middle income nations. It was estimated that by year 2030, about 60% population will be residing in the urban region. And by 2050, about 70% population will be urban. That is 6.2 billion population will be the urban population. Hence, urban flood will hamper more population in future, and that's why this is a concern for administrator, planners, and the governor and the citizens. So, as I mentioned, we will discuss the how urban flood is different than the rural flood and how this urbanization impacts the flooding and drainage. So, first, let's understand that from damage perspective, both causes damages to life and property, but economic damages are higher in urban area. The depletion of flood water in the urban area takes time due to construction activities and infrastructure, because there are continuously the flowing water has a restriction of flow because of the construction activities. The population density in urban settlement is more, hence it is prone to more damages to life. And during development, most of the natural streams are buried, they are damaged or disturbed. Hence, drainage system gets collapsed and proper drainage becomes an issue. Many a times, what happens? The quantum of rainfall falls on the ground becomes a runoff. So it becomes very challenging situation because there is a no infiltration in the ground. So whatever quantum of water falls on the ground, it's started flowing and converts gets converted into runoff. And the flash floods occurs in the case of retaining wall fails in urban area. So what happens in the due course of urbanization? Many a times we as a city planners or as a builder, they construct a retaining wall alongside of the nala or river. So if that retaining wall fails, then it causes flash floods, which causes more damages and which are caused due to the suddenly inflow. So damages will be more in the slum area as there are poor protection infrastructure, and most of the slum area is situated along the drainage nala side or river side, which is vulnerable to the flood risk. In urban area, most of the area is paved because of the road construction of concrete road or bituminous road or paved footpath or buildings or blocks, and because of this infiltration of water is low. There is a overcrowding, there is an unplanned urbanization, there is a choking of drainage because of the poor solid waste management. So even though there is a drainage provided for storm water, it gets choked because of the solid waste, which gets clogged in the drain. Then sometimes it happens that the low-lying area is filled with the construction material and new buildings or roads are constructed. So it adversely affects the drainage pattern. Then sometimes over extraction of groundwater, it creates a cavity underground, and if there is a flood, this causes a subsidence. So suddenly a area gets suddenly drowned, and it causes a landslide and subsidence. Then there are a lack of flood risk management activities. So in the next slide, we will discuss the impacts of flood. So basically, there are three types of impacts. First is a tangible direct impacts. Second is tangible indirect impacts, and third is a intangible impacts. So what are the tangible impacts? So tangible impacts happens because of occurrence of damage to the buildings, Infrastructure like road, bridges, health center, post office, school buildings, or damages to the crops, tools, or livestock. Then tangible impact also occurred because of the fires and because of the crop and land contamination by soil by seawater. As we discussed, sometimes seawater intruded in the soil, which causes soil salinity. The damages also caused because of the electricity cuts, and because of that, we cannot operate our machines and computer and communication system collapse. Then property deterioration and decay starts. There are long-term rots and dam. Then weakened infrastructure, and there are more damages prone to further flooding or disaster. These are the tangible impacts. What are the intangible indirect losses? So flood also cause losses to the agriculture and industrial production. It also causes loss of communication, loss of healthcare facility, loss of utility supplies like electricity or communication. It also contaminates the water supplies. The food and water supply chain gets disturbed. Some person lost their income opportunities, and this also result of price inflation. Then some business becomes bankrupt. There are various case studies how many cities became bankrupt because of the flood. Some business lost their investment because of the washing away of their asset because of flood. Disruption of employee flow at work, because there is a employee cannot reach at the workplace at the proper time, and he might be lost his life because of flood event, and because of that the company losses their human knowledge base. Then it also results in a loss of exports, and ultimately it results reduced national gross domestic product. And apart from this, there are intangible, huge human impacts. First is a loss of life, which cannot be counted in terms of money. Then there might be a physical injury, loss of heritage or archaeological sites. This also caused because of the flood. Then there is an increased stress. Then there is a physical and psychological trauma. Increased waterborne diseases after flood happened. Increase in the health condition, decrease in the health condition. Then there is a increased mortality rates. Then there are some social issues like homelessness, displacement, increased vulnerability to further shocks, and there is a disruption of the communities and cohesiveness of the community. So there are financial impacts, there are indirect financial impacts, and there are the ecological or human impacts. So now we'll discuss why flood really occurs. So in order to occur flood, two important things matters. First is a inflow discharge. So contour of water coming from rain or from melting of ice is contributing for the flooding. So, and second is a flow constraint. So if there is a space for incoming water to drain out, then there will not be inundation or flooding. But if inflow is more than the discharge carrying capacity of the stream, then flood water gets inundated out of the bank. And because of more inflow or because of flow constraint, generally flooding occurs. So what are the causes of flooding? First, because of from flow discharge side, there are five causes. First, intense rainfall. Second, melting of ice, and sometime in Himalayan part these two happens with single time. Then because of flood, if there is a landslide, then because of tsunami and because of dam break. So from inflow side there are these condition, and from flow constant side there is a river. The carrying capacity of river is important. Then there are low lying areas. Then river characteristics also plays an important part in order to flow this water. For example, slope of river is very gentle, then velocity of flow will be less, and hence discharge carrying capacity of the river will be less. Then encroachment in the flood zone is also cause of a flood. And sedimentation. So sometimes river brings sediment with flowing water, and if these sediments get deposited in a river bed because of the standing pool of water or less velocity of the water, then it creates a less cross sectional area for the flow of water. And because of these two things, generally flood occurs. So flood damages are divided into two parts. First, damages caused due to the standing water. So these includes soaking, dissolution of the water in some our property, and it makes our ground unstable and muddy. And second, it also sometimes cause drowning. And there is a damages because of the rushing water. So water crashing into building, cars, and other things. So this water literally wash away everything comes in its way. So, from study, it has been found that if there is a 15 centimeter depth of water, fast moving water, then a person can be drawn away. It can be flown away with the water. A water of 40 centimeter deep can carry away most automobiles. So if even though sometimes we had many times we saw viral videos that bus has been washed away with the flood water. So even we don't understand that even though water depth is only 40 centimeter, it has a too much power, and because of the less friction between the road surface and tire, the all the automobiles gets washed away with the flood water. So we should take utmost care while traveling on a road, and if there is a flood alongside the road. And generally rushing water dam kills many peoples and animals. So who is really responsible for the flood? So there is a debate across the world regarding is flood is act of God, that is a natural, or it is an act of human. So this debate will be continued, but in order to answer this question, there is a no straightforward answer because this is an intermixed phenomena. And on one side, we can argue that since ancient period when there was no development or human was not developed, then also there were incidents of flood. But the flood impacts get magnified because of the human activities such as deforestation, unplanned urbanization, global warming, river encroachment, and damages to the natural drainage system. And there is a theory which says that the famous Indus Valley civilization lost because of the flood. So we can say that ideally, floods should occur because of the natural reason, because of the excessive rainfall, or because of the less carrying capacity of the river or drainage system. But its intensity gets multiplied by the action of human. So, at present day, we can say that a flood is a intermixed phenomena. And if you see, if we analyze the past floods, so, Dartmouth Flood Observatory carried out a research and they found out that most of the floods were resulted from heavy rain. The second important contributor for the flood is a brief torrential rain, then tropical cyclone, then monsoon rain, snow melt, and another next is a dam break, then ice jam or breakups, then extra tropical cyclone, tidal surge, and avalanche. So this is a general trend of why floods occur. If we summarize the last 40 years flood data, and if we classify them across the globe, then we can understand that about more than 60 event occurred in India. So India, as in the first slide also we discussed, India is very prone to the floods, and that's why we should have proper flood mitigation policies. So in the upcoming slide, we will discuss various types of flood. So floods are classified into four parts or four types. First is a river floods. Second is a sustained rainfall floods. Third is a coastal flood, and last is a flash flood. So in the next slide, we will discuss each type one by one. So first, river flood. So it is very simple to understand that river floods is occurred because of the less carrying capacity of the river system. So if there is an intense rainfall and this rainfall cause a runoff, and this runoff volume is more than the carrying capacity of the river, then water passes through the bank of the river, and this cause a flooding in the adjoining region. So river floods are predictable because it depends on the rainfall intensity. And if we know rainfall intensity or prediction of the rainfall, and if we know the how much quantum of rainfall gets converted into runoff, so there are some empirical or some theoretical or some models available in order to get rainfall runoff relationship. Through rainfall runoff relationship, we can arrive at the quantum of runoff. And if we know the time of concentration, that means how much uh, so how flow will behave and what will be the catchment pattern, then we can predict how much what quantity of flood water will arrive at a particular point. So hence these are predictable, they are comparatively easy to manage in order to make a mitigation plan. And these generally river floods are occurred during a specific period of the monsoon. So advance warning and evacuation in river floods is possible. And in order to avoid river flooding, we can have flood line regulation. So we can use red line, blue line in order to avoid encroachment in the flood river system. Then second is a sustained rainfall flood. So in sustained rainfall flood, these floods are caused due to the intense rainfall or cloud burst at a specific location. So every terrain has a certain slope, or if that terrain, for example, in Buldana we have Lonar Sarovar. So if water rainfall falls on that Lonar Sarovar, there is no point of discharge until it reaches to the high reach point. So in such cases, there will be the inundation of the land. And if rainfall duration is larger, more area will be prone to the inundation. So it generally occurs at the flat terrain where drainage is a problem, and generally in a city, sustained rainfall is a big issue. So in Pune, if there is a rainfall of magnitude of more than 50 millimeter in a one day or 2 3 hours, then we can see that there is a issue of all the waters come on a road, and it causes a traffic jams and blocking of the natural drainage system of the city. And it is very difficult to tackle such issues. In Mumbai also we suffered because of sustained rainfall flood. In Chennai also this problem considered. So based on the type of flood, this mitigation strategy differs. The third type is a coastal flood. Sorry, the third type is a flash flood. So flash flood occurs because of the rapid flooding of the area because and caused due to the rapid rainfall. So flash floods are characterized by the time scale of fewer than 6 hours. So if flood occurs within a 6 hour period, and yes, if flood occurs because of the rainfall which has been occurred within a 6 hours, then it is treated as a flash flood. And it generally caused because of the heavy rain associated with the severe thunderstorm. And generally flash flood also occur because of the glacial lake outburst flood, and it also occurs because of the collapse of a natural or ice debris in water. And flash floods also caused because of the failure of man-made structure like dam. So flash flood causes huge loss. It has less time for evacuation, less time for strategical planning, and there is a less scope for regulation and less scope for advance warning. So from management perspective, flash floods are very difficult to manage. Last is the coastal flood. So coastal flood, so the ocean is vast, covering about 363 million square kilometer area of this earth, which is about 72% of the earth's surface. And more than 600 million, that is about 10% world population, live in the coastal areas that are less than 10 meter above the sea level. And nearly more than 40% of world population live within 100 kilometer of the coast. And coastal flooding occurs when dry and low-lying area is submerged by seawater or floodwater. So coastal flooding can cause a significant biodiversity loss and potentially space causes a extinction of some important species. The prolonged inundation of seawater after flooding can cause a salinity, and it reduces the agricultural productivity of soil, thus resulting a loss of productivity for a long period of time. So coastal flood is a very challenging issue in management, and as Maharashtra has about 720 kilometer of coastal line, so management of coastal flood is also important from that perspective. And there is another challenge. So the intergovernmental panel on climate change, so they anticipated that the global mean sea water level will rise from the rise between the inter global mean sea level will be 9 centimeter to 88 centimeter by year by the 22nd century. So this will cause increased intensity and frequency of storm events such as hurricanes caused due to the climate change. Thus, coastal flooding from storm surges will become more frequent with sea water level rise. And there is another impact of the coastal flooding. So flooding caused because of the tsunami waves. So tsunami waves causes intense damage because it has a high rise. The height of wave is very high, and the speed of wave propagation is also very high. So tsunamis are caused due to the displacement of a significant body of water, because of it may be caused because of earthquake, landslide, or volcanic eruption and glacier calvings. So the destruction is caused because of the velocity of the approaching wave, height of the wave when they reach to the land, and because of the debris floating on the water that enters over land, which further signifies or intensifies the damages. And we discussed this flash flood. So, the important concept in flood management is measuring the flood. Like we measure the intensity of earthquake by Richter scale. So, how really we measure flood? So, unlike earthquake and hurricanes, flood do not have a standardized rating system that that can be used to measure its intensity. However, there are three factors which decides the magnitude of flood. Which are these three factors? The first factor is a stage. Stage means depth of the water, flowing water. Second is a discharge. How much quantum of water is passing in a given area in a certain period is known as a discharge. And third is the extent of the inundated area. So the quantum of area which is underwater is a inundated area. So these three factors, that is the stage, discharge, and inundated area, contributes to the assessment of the flood. And the size of flood is measured on a recurrence interval system. So, based on the probability of occurrence of flood in 100 years period, we can classify a flood as a 10-year flood, 25-year flood, or 100-year flood. And larger the interval, bigger the flood. And there is a classification by Dartmouth Flood Observatory. So this observatory classified flood into three categories. So in class 1, they classified large flood events, and these events are cause significant damage to structures or agriculture, and it also cause fatalities, and there are 1 or 2 decades long reported intervals since last similar event. Then class 1.5, they classified this event as a very large event. So in very large event, there are the impacts are greater than 2 decades but less than 100-year estimated recurrence interval, and this causes a damage to the area more than 5,000 square kilometer. And the last is a class 2, that is an extreme event, which is a unprecedented events, and these events are estimated has a estimated recurrence interval greater than 100 years. So in the large flood events has a recurrence interval of 1 or 2 decades, that is 10 or 20 years. The very large events has a recurrence period of 20 years to 100 years, and extreme events has a recurrence period of more than 100 years. So after knowing the basics of the flood, we should come to the management of flood. So the flood cannot be uh, controlled, but it can be managed. So there is a difference between flood control and flood management. And in order to have manage the flood, we should get the early warning system in place. So the basic components of early warning system includes historical data. The second component is the details of drainage basin or digital elevation model of the terrain. And third important data which is required is a real-time rainfall data. So if we have these three things, we can prepare a model, which this model will study the historical data of the rainfall runoff, the drainage basin characteristics, and it can predict the flood outcomes. And if we get the flood value from our model, then we can give this flood value to the input to the our computer system, and we can prepare flood maps. And once we have this system is ready, so in the simulation or in the real time in the forecasting phase, if the upcoming rainfall data is provided, then we can get a flood alerts. So once early flood warning system is in place, then it will help us to get the flood alerts if we know the rainfall upcoming rainfall intensity. So now we will discuss the important provisions of the Disaster Management Act 2005, and this act is very important from managing any disaster, not only flood but all the disaster. And this act provides for the effective management of disaster and matter connected with therein. And this act was enacted by Parliament and got permission approval by the President of India on 23rd of December 2005. This act was notified on 26th December 2005 and came into force on 1st August 2007. And this act is applicable to whole of India. So management of disaster. So as per this act, disaster shall be managed at four level. First is it should be managed at national level. So how disaster management happens at national level, we will discuss in next slide. Then disaster management at state level, disaster management at district level, and ultimately disaster management at local level. So at national level, there is a National Disaster Management Authority, that is NDMA. So chairman of this authority is Honorable Prime Minister, and there are 9 members which are nominated by the chairman. So objective of this NDMA is to formulate the policies, prepare a national plan for disaster mitigation or management, and to recommend the fund provision for disaster management. Then there is a National Executive Committee, and this National Executive Committee assists the National Disaster Management Authority, and Secretary Ministry of Home Affairs will be the ex officio chairman of this committee, and there are various secretaries who are members of this authority committee. So their task is to prepare national plan and national policies, to provide technical guidance to the state government for preparing their disaster management plan, to evaluate preparedness of the all state governments, and there is at the last there is an advisory committee. So advisory committee can be constituted by the national authority, and central government can fix the number of members in consultation with the national authority. So this advisory committee's role is to advise to the government. At state level, there is a on the similar lines there is a State Disaster Management Authority. Then Chief Minister is the chairman of this authority, and there are 8 persons nominated by the chairperson. And chairman of the State Executive Committee is the ex officio chairman and ex chief executive officer. So there is a State Executive Committee which assists the state authority, and chief secretary is the ex officio chairman, and there are other 4 secretaries as a member. So this State Executive Committee implement national policies and prepare or approve state plan. And there is also State Advisory Committee which consists of the expert. So at district level, there is a District Disaster Management Authority, and collector is the chairman of that authority, and there are many members and public representatives as a member of this authority. So this authority prepares disaster management plan and they implement national and state policies. And at local level there is a authority which ensure that there are the offices and employees are trained for disaster management. It ensures that resources are maintained and readily available in case of disaster situation arises, and there are offenses and penalties are mentioned in this act. So it is very important. So in order to have proper disaster management plan, we should the person interested person should go through the provision of this plan. So in this third part, I very briefly I will discuss the flood vulnerability of the Maharashtra state. So in Maharashtra, as we know, there are five river basins: Krishna River, Godavari River, Tapi River, and Narmada River. So these four river basin contributes 45% water, and this water is utilized for the 92% of the cultivable land of the state, and remaining 55% water is in the west flowing rivers. So you can realize that the water is uh, the distribution of water is there is an issue of spatial and temporal availability. So these five river basins are divided into 25 sub basins and 1505 watersheds. If we see the yearly rainfall of the state, it varies from 400 to 6000 millimeter, and average rainfall is 1067 millimeter. So 90% of the rainfall occurs during the monsoon period, that is June to October, but there is a spatial and temporal variation. And if we see these 4 months of the monsoon season in a year, then it will calculate the actual rain days. Then in the 4 months of monsoon season, the actual rain days are only 40. So during the out of 120 days, only 40 days will have rain. So if we count the number of rain hours during the 4 months of monsoon season, then 96 hours will be having rain. So we can realize that we get rainfall only during the 96 hours, that is 4 days in a year. So it is a very big challenge for water resource managers to store this water in the dams or hydraulic structure without causing a flood or without sacrificing the storage condition. And there is a 40% area is drought prone and 7% area is flood prone. And topography of Maharashtra is like that. There is a Sahyadri mountain on the western side, and whose height is more than 650 meter. The rainfall is very huge. Rainfall magnitude is more than 5000 millimeter, and most of the dams are catchment area of this dam are situated in the Sahyadri mountain ranges, and dams are situated at the in the valley, and rainfalls at the dam site is about 800 to 1200 millimeter, and most of the cultivable area is on the east side of the state, which is a flat terrain which has a cultivable land and which receives a rainfall of the magnitude 300 to 600 millimeters. So on one side we get the most of the rainfall from western side, our utilization is on the eastern side. So because of the time constraint, I will skip some of the slides. And if you are interested, I will share this presentation. You can go through this presentation. And the Sahyadri mountain is plays very prominent role in the our monsoon management. And this mountain has a cultural, environmental, geographical, biological, and hydrological importance for the state. And this plays very important role in the monsoon management of the state because it stops entry of clouds into the Deccan Plateau. And there, as I mentioned, there are five river basins. Out of those five river basins, four river basins are situated on the east side of the Sahyadri mountain, and one river basin, that is the Konkan west flowing rivers, are on the west side rivers. So I will skip some of the slide, but I just want to make a point that because of the uh, impact of the climate change, the occurrence of the flood events will be more, and there will be intense rainfall in a short period. There can be a cloud burst, and which can result in a flash flood. So we are experiencing these events, and in 2019 also we had experienced several events. So what are the reasons for the flood? First is the intense rainfall, prolonged rainfall, and the geographically spread rainfall. Second reason is a characteristics of the river, the slope of river, meandering in the river, less carrying capacity of the river, sedimentation are the issue. And there is a debate between the effect of dam on floods, but that is a different topic, so I will not touch that topic in this presentation. So at the last I will just discuss the flood management and way ahead. So disaster management strategy. So in this strategy, the first step is to understand hazard and vulnerability. So in this figure, hazard means falling a rock on over the head is a hazard, and vulnerability is standing below the near the mountain where there is a possibility of falling a rock. So first is the understanding the situation. So when disaster can happen. Second is what will happen if disaster happens. So that situation should also be recognized. Third step is the prevention. If we know what is a hazard, what is a vulnerability, and what is a disaster, then we should think first about the prevention, how this disaster can be prevented. For example, in this figure, it is shown that this rock has been bolted with the help of rope. Next step is a preparedness. So in case we cannot prevent the disaster to be happen, for example in case of our flood, it is not possible to control that disaster. So important step is preparedness. So in order to be prepared, be ready for the flood, we should have a preparedness and mitigation plan. And mitigation includes to, even though we cannot control outside world, we can control our surroundings. So mitigation and preparedness are the two important things. So flood mitigation includes three important activities. First is the flood forecasting. So there should be reliable advanced information system about the impending floods. Second is the flood inundation mapping and land use planning, and this is a domain where all the technologies and technological faculties and academicians can enter into. And they can study, they can bring the technologies such as remote sensing, drone technology, artificial intelligence in order to study the flood and its inundation. And third is a having a decision support system for real-time flood warning and management. So based, as we discussed, based on the database linked with the mathematical or hydrological models, based on the hydrometeorological information, we can decide how much flood intensity will be there, which area will be inundated, which are the critical locations which should be evacuated, and what will be our response for the upcoming flood. So, response, mitigation, and preparedness are the important words, and there are various strategies given in the literature. So, I will not go in detail, and this is the last slide of my presentation. So, way ahead, the number one concern is more population will be in urban area. As we discussed, about more than 70% of the population will be urbanized in by 2050. The second summary or second conclusion we can draw is that urban population is more vulnerable to floods, and there will be more damages to the life and property. And flood damages are higher in urban areas, and there are after effects not only during the flood period, there are after effects of the flood. Effective planning and management of the flood is utmost important. The flood lines shall be marked, which is just like a preparedness, and these floodlines shall be regulated in order to avoid encroachment in a river system. Early flood warning system and flood management plan shall be prepared. And last and most important is the climate change will worsen the situation. Hence, utmost attention shall be given in order to avoid urban flooding. So that's all from my side. Thank you so much. Hello. Pallavi ma'am, over to you, sir. You ma'am.
Hello, am I audible?
Yeah, yeah, ma'am.
Yes. If anyone have any questions, they may ask.
Hello.
If
Hello.
anybody
Yes, sir.
have any questions, please ask your queries.
Uh, my question to Dr. Kole sir is, sir, even after so many interventions and urban planning, so cities like Mumbai have huge problem during the monsoon seasons. So, is it mainly due to the insufficient sewer systems, or how do you foresee this problem, sir?
Yeah, sir. Very interesting question, sir. Sir, there was a committee under chairmanship of Dr. Madhurav Chitale, and his report is available on the website. It is very interesting and very detailed report. And in this report, they cited various reasons for flooding in Mumbai, and the two important reasons are its geographical location. So
Mhm.
the elevation of the Mumbai is very the elevation difference between the sea level and Mumbai's ground is very less. So because of this, what happens? So most of the drainage we release into the sea. So when there is a intense rainfall within a city area, the drainage is expected to happen, and all the runoff is expected to go to the sea. But what happens if there is a high tide situation? The flood water cannot enter into the sea, but sometimes sea water enters into the ground. So in such situation, the flood management becomes very difficult. So apart from the all the points we discuss in this presentation, this is another angle for the Mumbai city, and hence the management of flood in a city like Mumbai, because it is a highly urbanized, quite developed, and it has a varied population and varied state of infrastructure. And this geographical and topographical issue and drainage system makes our problem much difficult. So this is a important concern for Mumbai, and because of the climate change, the intensity of rainfall is increasing. So we cannot have a very big sewerage system to carry out the storm water. So there is a limitation from development side. So there is very little scope for managing the storm water.
Sir, in developed countries, so do they do something different in such situations, sir?
Yes, sir. There are many examples like in Japan and China. In China, I will first cite the example of China. In China, they started developing a soaked city platform, soaked pavement technology. So, in soaked pavement technology, whatever water falls on road or pavements or a garden or open ground, so they have soaking mechanism. So the permeability of that soil or that material or that concrete component is very high, and whatever water falls on that land or that material, which is percolated through that material, and it gets collected underground. So this system is available in some cities of the China. And in Japan, it is very interesting to know that they had constructed underground drainage system. So they had below the road they had constructed two or three-story the storm water tunnels. So these are very huge infrastructure. You just go to the YouTube and just Google, just look for the Japan's flood mitigation infrastructure. So they in Japan they had huge infrastructure below the ground. So all the storm water coming on the ground, which falls on the ground, it is collected through underground tunnels, and these tunnels are interconnected, and the storm water is taken out. And whenever it is required, they pump this storm water if there is a elevation difference between the two connecting tunnels. So this is very interesting, but because we have financial constraint and there are other issues, so it is very difficult to replicate these issues. But ultimately, the day will come where there will not be any scope, and it will be mandated. It will become a mandate for us to adopt such technologies.
Thank you, sir.
Thank you, sir.
Yes, sir. We have some questions in our chat box. So Those are
Yeah,
uh,
yeah.
Professor Dilip G. Patil wants to ask, is there any need to change in urban planning rules and regulations? And what will be the long-term solution for the new towns at least?
So this is the area where accommodation can give input. So there so from regulation perspective there is a little scope. Why I am making this statement? Because flood is not a universal phenomena. So urban planning with vis-a-vis flood mitigation in a city like Mumbai is a different issue, whereas urban planning in Yavatmal will be different, in Nagpur it will be different, in Kolhapur it will be different. So the rules and regulation cannot in isolation can solve this problem. So rules and regulation which are conversant or which are related with that uh, topography are most important. So rules and regulation are required, but I think rules and regulation is a second step. First step is to have proper drainage system. That means, as we already discussed in the one of the slide, that first we should understand what will be the highest intensity rainfall in upcoming years. So as we study, I have skipped some of the slide. So because of the climate change, the intensity of rainfall is expected to be increased. So there will be more rains, and further to add, these intense rainfall occur in very short time. So first step is to calculate the rainfall intensity and its duration. If we have that extreme rainfall intensity and duration, then second step is to have digital elevation of model of our city. So if we know these two details, then we can super overlay the incoming water on the city area, and then we will get the inundation area. And from these two inputs, we can arrive at the development plan. So what I think, there should be a broad guidelines or broad level rules and regulation, but its planning should be local level. And I think in a program of smart cities, they are trying to analyze these situations, and they are trying to make the cities less vulnerable to the floods. So there should be a proper arrangement for collection of the incoming storm water, and the immediate drainage of such water is utmost important. So yes, you are right that there is a need for urban planning rules and regulation. And I think if we go as we discuss that, first know the highest level rainfall event, then have the inundation mapping, then third have disaster mitigation plan, then it will provide a long term solution for a given city or town. Thank you, sir. Hope my answer satisfies your question.
Yes, sir.
Yes,
Thank you,
he
sir.
already has said thanks to you in chat
Yeah,
box
thank
also. Yes, Patil sir, if you want to say anything.
No, madam. Thank you. Thank you, sir.
yeah, thank you.
Yes, thank you very much, sir, for such a wonderful information. Now, if anyone has some questions, they may ask.